Alright, sorry for the abrupt ending on the last one. I only have 10 minutes on YouTube and I was running out of time at the last second. But I got to work, so I went through that last one real fast, but just to clarify at the end that we have an and being used, so we have to take where they have in common. So the blue line was shading this way, the red line was shading this way. So that's where they overlapped. So we really then could just take away the rest of it, because we do not, the book is giving you answers that do not take the overlap, or that do not take the anything else that doesn't fit when we use the word or and. So they're very specific. I will not be as picky. You'd be okay to say, to leave everything on there. I know what I'm looking for. So, but we'll compare with what you have in the back of the book. Now these two, we have this one right here, which is one variable. If it's one variable, it's going to be either vertical or horizontal. And we have x is less than 3. So 3 is right here on the x-axis. So since that's the axis it's intersecting, it's going to be a vertical line. Again, it's less than, so it's dotted. And it says less than, so we will shade this way. Now notice that this time we're talking about the word or. So I will not need to be as picky. I'll just leave it as is. This one is two variables, so it will be a diagonal. You have no y-intercept, so that's 0. You have 1 in front of the x, so that's 1 over 1 slope, so up 1 over 1, up 1 over 1. It has a line underneath it, so it's solid. And you want to shade greater than. Again, here's your y-axis. As you go up, it's greater than. As you go down, it's less than. So they want us to shade greater than, so we shade up. Now this one would shade above the line we just drew. And we have an area in common, which would be right over here. But since it's or, we don't have to be shading in just that area. It takes everything. So anything that has a shading to it would work when it's an or. Now, in 7.2, we're going to talk about the beginnings of argument. And with that comes some needed terminology. The two that I have given you here are implication and conditional. And a conditional is an if-then statement, and we'll have plenty of those as we go. Implication is a statement with an if part and a then part. The if part is the hypothesis, and the then part is the conclusion. So right there in that definition, you have the definitions of hypothesis and conclusion. The if part is the hypothesis of an if-then statement. The then part is the conclusion. So if this, then that. So hypothesis is the if, and the conclusion is the then. So I'm not going to write anything else up here for hypothesis and conclusion because they are written here and here. Now to start the notation, there is this arrow, which is not here. I'll draw that in. That's the arrow for an if-then statement. And what it tells us is all of these things, they all represent the same thing. If P, then Q can be written with this notation. And we want to get comfortable with this. If I write P arrow Q, it means if P, then Q. Now keep in mind, that makes this the if part, and the Q the then part. So this is the hypothesis, and this is the conclusion. So how does it look in a sentence? If P, then Q is the most obvious. Every P is a Q. So if it means, they say it, every P is a Q, it means this. P implies Q, and P only if Q. So all different ways that you will see that in your homework. Here we have an example. The sum of the measures of a rectangle is 360. Write it in the form of P arrow Q, P arrow Q, which means basically write it in an if-then statement. So we will write if, this is one way to do it, if the figure is a rectangle, then the sum of its angles I'm going to do a shortcut for angles. That means angles is 360. Okay, so that's writing it in a different form and in the form of if-then. So notice I have if the figure is a rectangle, then the sum of its angles is 360. When you write it that way, you'll be able to tell what is the hypothesis. The hypothesis is that the figure, if the figure is a rectangle, the conclusion is sum of its angles is or equals 360. Now, is this implication true? Well, if it's a rectangle, what do you know? Are the sum of its angles 360? In this case, yes, it is true. What's the converse? Well, converse represents you taking the if part and the then part, in other words, the hypothesis and the conclusion, and switching them. So we basically would just reverse the order. So we would say if the sum of its angles is 360. Oops. Going too fast for my computer here. Is 360, then it is a rectangle. Or then the figure is a rectangle. That'd be more appropriate. Alright. Rewrite each implication in if-then form and tell whether it is true or false. If it is false, give a counterexample. Write the converse also and tell whether it is true or false. Every number divisible by 5 ends in 0. Okay, well, every. There's the notation. Every P is a Q, represents if P, then Q. Every number divisible by 5 ends in 0. So we would write, to put it in if-then form, if a number is divisible by 5, then it ends in 0. Is that false? Well, let's think of a number, 25, for example. 25 does not end in 0, yet it's still divisible by 5. This is false. Okay, and then again, for example, a counterexample is you proving it, and that is counterexample. $25. I'm at 9:24 here, so I'm going to stop. I'll have one more video to finish this one up, and then you can start on your homework.